so here we're going to take a look at the spanning sets of null spaces. Alright, so let's say that we had just some matrix A, which we define as -1, 3, 1, -6, 2, 1, 5, 5, 1, 2, 4, 1. Okay. And I want to find the null space of this, right? So the problem we've done before, right? We would reduce row echelon form this matrix, and this will reduce to 1, 0, 2, 3, 0, 1, 1, -1, and then a row of zeros. So we have two pivots, and let's say we have three free variables, right? We could say, all right, we have x4 to be s, x3 to be t, or again, just leave them as x3, x4, right? And then we could see for x2, right, from our second row, we'll have, so plus x3, which I call t, minus x4, which I call s, again, equals to 0, so this means that x2 is equal to s minus t. And then here, x1 plus 2 x3, which is t, plus 3s equals to 0. And then solving here, we get x1 to be -3s plus 2t. Okay. And then from here, we can write this as the vector s -3s plus 2t, s minus t, and then t and s. Such that s and t is any real number. Okay, so that's what we would, before we'd say, all right, this is the null space of A. Right, we'll work through it in that fashion. Now, let's focus here on that vector of the solutions here. If I focus here on this, I can rewrite this as -3s, s, 0, s, and then plus 2t, -t, t, 0. Right, or even further, I can write it as a scalar multiple okay, so this represents any element of the null space. Right, it has this form, right? Well, if we notice here, this is nothing more than a linear combination, right? So the null space is actually the set of all possible linear combinations of these vectors. Well, that is what we define to be a span, right? So in finding the null space, I can treat these vectors that I find, depending on how many free variables I have, right? I can treat them as some set S, right? So I can call S to be a pair of vectors corresponding to the dependent variables. Right? In this case, we had two pivots, so we had two vectors. All right, So that's the set defined by those vectors. But now I can write the null space of A instead of the set notation that I had before. I can write it as a span of those sets, right? Because that is exactly what the null space is, right? It's just a set of all possible linear combinations of the solutions to our homogeneous system there of the matrix A.